Yeah? Okay. So hello everyone, I'm very excited to be here. My name is Dana, and I'm a software developer, like all of you probably. I'm from Israel, and I'm working for a company called AppsFlyer. And I will be talking today about debugging with the REPL-based debugging in Clojure. And actually, I started working with Clojure almost 2 years ago when I joined AppsFlyer. And I'm lucky to be using it today as my day-to-day programming language. So a little bit about AppsFlyer before we start, where I come from. So AppsFlyer is the world's leading mobile attribution and marketing analytics platform. We help our customers to get better insights on their campaigns and in general to make better decisions. So what is mobile attribution? You're probably asking yourself. So it's basically, to keep it simple, when a user clicks on an ad, then he maybe install an app from the App Store, from maybe it's an iOS, maybe it's an Android, and then we match between events that are sent from the app using our SDK to our servers and to the click and install, and by that we have better insights on the campaigns, where the user comes from, and help our customers to understand how their campaigns are performing. So AppsFlyer and Clojure is a love story. Actually, it's our main programming language, our main backend programming language. And we have more than 200 developers using it. Most of them are using it in their day-to-day. So we are a large Clojure workshop. We have more than 200 microservices running on production. Most of them are written in Clojure. And all this operation is done by around 1,500 servers. We process, and look at this, we process more than 90 billion events per day, which is huge. And our scale is just getting bigger and bigger. And our SDK that I mentioned before is integrated in more than 95% of the devices around the world, all kinds of operation systems. So probably all of your devices somehow contains our SDK. So every new developer, or all new developers in AppsFlyer, starts their journey with Clojure, with a Clojure training. They learn the basics of the language, write some Clojure projects. And when I started this training, I had to figure out which environment I want to set. So I set up a REPL and then an editor. To be honest, I chose Vim, so Emacs users. I will understand if you choose to leave. No one is perfect. And then I started writing some code. It was okay, but I wasn't sure how I should debug this code. I mean, debugging code is really basic. It's like the basic thing that a developer does, right? But something with Clojure, with the REPL, with the editor, reloading the code, everything, I wasn't sure if there's a right workflow that I should follow, or maybe is it something that I have to figure out alone? And then I started exploring it. So this talk will be totally back to fundamentals. It will cover some basic stuff, but basic stuff is our everyday stuff. So I hope you will enjoy it, no matter if you're totally new to Clojure and asking yourself the same questions as I did when I just started, or even if you're experienced Clojure developer and have your own workflow and everything works fine for you. So I will share with you how I learned to use some basic tools like the stack trace and prints to help me understand my workflow better and my code flow better and debug my code. This led me, this exploration phase that I went through and still going through, led me to write a Clojure library, a small Clojure library, which is called mate-clj. And basically it aims to help developers, Clojure developers, to debug their code and understand the code flow better. And in general, we will try to understand, is it the right approach when talking about debugging Clojure code, working with the REPL, or is it something individual? We will see. So to start, as I said, it's a base. We are going back to fundamentals, so the REPL. The REPL, as you probably know, stands for read, eval, print, loop, and it basically gives us an environment which we can interact with our running Clojure program. And of course, it gives us a fast feedback loop, which makes our workflow much more faster. It's a great tool. We all can agree about it. And a small disclaimer, I will be talking today about REPL, but the ideas are kind of like the same for all the REPLs around there. So let's start. We can start with the worst thing that can happen to a developer, and especially to a Clojure developer, the stack trace. So this is me. Every time I see a stack trace, I know that Homer Simpson and I kind of look alike. But yeah, we all know this, this feeling, and especially when it's a Clojure stack trace. So it's true that the stack trace can be threatening, but we actually all know that it's a good sign because while developing, in development, a stack trace indicates that we have an unexpected issue, an uncovered flow, and we now have the chance to deal with it and to handle it. But one thing that was surprising me when I started using the REPL is that it's actually not printing the whole stack trace. So when I tried to understand what's wrong, I didn't have the whole picture and the understanding of what is the problematic flow. And I had to go all over the flows that leads to this point and understand what was the issue and from which flow came the issue. And it got kind of tedious. And let's see it by example. So we have here a code. It has a state which has some data. It's mount dev states. Mount is a state-dependent state management library. It just stores some data. Then we have my divide function, and we have my calc function, which calling my divide function. Really simple. And let's see what happens when I try to call my calc function with the state arguments. So I get an exception, and again, not the whole exception. But what I can try to understand here is that it's arithmetic exception. I see that it's coming from my divide function, and I see that the issue is that I'm trying to divide something by 0. And of course, it's a simple one, but imagine yourself, you have several flows that leads to this my divide function, and now you need to start understanding where this flow coming from, and it will take time. And we want things to be fast because we are lazy, and we want to understand things immediately. So actually what I found out is that the REPL is storing the whole stack trace in a variable. It's a REPL variable called star E. And using that and knowing that, we can use it in order to get the whole stack trace and then understand the whole picture, and without any need to debug it and to understand it while debugging. So let's use the stack trace namespace, which have really great function, print stack trace. And passing this variable to this function will give us the whole stack trace, and by that we will be able to understand. So for this example, I'm just printing the first few lines, but it will print everything. And now we can see that the issue is not just in my divide function, but the flow that led to this function is my calc. And now it's really easy to understand the flow, and I can update my data, update my code, maybe both of them, and then resolve the issue I have. So if I want to update something in my code, as you probably know, I need to reload it. And if I'm updating the data, I need to update it and synchronize it with my code again. So this is the next topic, and we will talk about synchronization, because when changing something in the REPL, we need to reload it, and when it's only code, it's okay, but then when it comes to data and code together, we need to keep everything synchronized. So one option is to stop the REPL and start it again, but it will definitely interrupt the workflow because the REPL takes some time to start up, and every few minutes to stop the REPL, start it again. It's not something that we're interested in. As I said, we're lazy and we want things to be quick. So let's go back to this example we saw. I will, just to keep it simple, will update the value of A from 0 to 10, and I want it to be updated. So when I now call my calc function, I want a new result that relies on this updated data. So actually, as you saw before as well, and as you probably know, the REPL starts with a default namespace, which is the user namespace. And if you saw, you don't have this file actually in your source code. But if you will add a file, user CLJ, to your source code, it will be auto-reloaded and loaded to your REPL, and you will be able to use it as a kind of utility function, namespace, and we will see how we can use it to synchronize our code and data and to reload everything in one function call. So this is a simple example for this kind of file. It's create the user namespace, and then we have the main function we all know, and that will start our program, but now it will just call the reset function. And reset function will stop the state, so it will clear the data we have, and then refresh the code, so it will get the changed namespaces and reload it again to the REPL. Then by calling go function, we will reload the data again, and then have everything synchronized. So basically what it means is just clean the plate and start all over again. Back to the example. Now we will call the main function, and we can see that it's stopping all the states, then refreshing the code. We are able to see the namespaces that are getting reloaded. Then it will start all the states. When it's ready, we can use the code again. We can call functions. We can do whatever we want without stopping the REPL and starting it again. So now calling my calc, let's see if we get a different result than the exception. And yeah, we're getting an updated result. It's not the exception, and we have everything synchronized together back again. So state reloading is a cool method. It's cool because it gives the ability to use the default namespace, the user namespace, without adding new dependencies to our project. And it provides us synchronization between the code and the states data. And the most important thing, it provides us fast reloading, which is basically what we need in order to not slow down our workflow. And I really recommend you to go over this post by Stuart Sierra. It's covered much more deeply, and it's really interesting to read it, especially if you're new to Clojure. Really recommend it. So that's great. We now don't have more exceptions in our code, and we know how to synchronize everything together. But still, we need to debug our code, because sometimes or a lot of times, we are writing functions or code or whatever, and for some reason we're getting an unexpected result. It's not an exception, it's not an issue, but it's not what we meant to. And then we're trying to debug what we need to change. So let's see another example. It will be easier to understand it. We have here a map which is containing some information about this conference, the name and the location. And let's say that for this example, I want to take the string of the name, just the string, and then add another string to it. It's really simple. I will try to do it with threading macro. I personally really like and love threading macros. I think it makes the code much more clean and clear. And for me, it's really easy to see the steps. So I will take the map, get the name, convert it to uppercase, and just add fun. So let's see what I get. I will run this function. and oops, I'm not getting what I wanted. I say I wanted just a string, but I'm getting a printed vector or some kind of a weird result. I'm not sure why, and I need to start debug my code. And I think that using a simple method like print will be a good method in order to understand what's wrong. So print is simple, right? It's the most simple tool I think we have. Again, it doesn't require any new dependency, and it provides fast feedback because it's not something complicated to run. And the most interesting part that we will see is it can be combined in functions and macros and provide us easy workflow. So let's see. Back to this threading macro, but now just adding 3 lines of code with the do-to function that takes an argument, executes the functions, and return the same argument. So we won't affect the threading macro functionality, but we will get the execution steps, the result of the execution steps printed to the REPL. So now I'm getting 3 lines printed and the same final result. And going step by step, we will see that the first result is the map. Then we have the result of getting the name, and I can clearly understand now that the issue is here because I'm getting the vector, and I say that I want only the string. And now the third execution. So by adding just 3 lines of code, and in less than, I think, 1 minute or even less, I can now understand that by adding the first function will solve my issue, and I can continue on. So this is the expected result, and I'm happy now. That's great. And I started using this method a lot, especially when I was a beginner to Clojure, and I was trying to figure out what every macro and function does, because sometimes it's not that obvious. But then I realized I can't really add print by print by print, and if it's a long Clojure project or namespace, then I'm getting lost by the prints because I have a lot of prints. And I needed something else that will help me. And I'm sure that you all are not adding a lot of prints just to understand your whole workflow. It's good for 1 function or 2 functions, but not more. So you don't really need to do it because you can use mate-clj, the library I wrote. And it is a result of this exploration phase I did, and I tried to understand how I can combine those prints with some functions and macros, and even core functions and macros, and by that understand how they work and what is the flow that my code is going through. So mate-clj will keep the functionality of the macros and function the same, but with an added bonus of printing to the REPL every execution step and the final result, of course. And let's see how it works. So let's add it, of course, to the REPL. And back to the same example we saw before. Now using the threading macro from the library. All the APIs are with the D. D stands for debugging. And now I'm getting printed to the REPL the result, the execution steps, and the result. And now I can see not only the results of each step, but also what is being done in every step, which gives me much more visibility and understanding on what this function does. Another cool example is using cond with a threading macro. So running this function will give me the final result of 918. I'm not sure why, to be honest. And if I want to try to understand why, I need to go step by step and then understand if the condition is true or false. If it's true, to make the calculation, and then if I'm not wrong in any step, I will get the final result. But using mate-clj, I can clearly see every step of the execution and what is the result of every step. And by that, the calculation will make much more sense. Another example is the reduce function. Again, it's a lot of calculation we can make, and by using mate-clj, I will see for each step what is the calculation, the result, and then how the result of each step is getting to the next step, calculation. And the final result, of course. So those were just 3 examples. There are more functions and macros that are covered. You're welcome to use it, and of course you're welcome to contribute to this library. We will be happy to get your contributions, and pull requests are always welcome. And the last topic I want to cover today is using logging libraries, because we need logs in our code to understand if there is something wrong or something right that we want to know about it. And using prints will give us this information. But let's say we want more information, not just the value or the message itself, but also, for example, when it was printed, where it was printed. So again, we won't get lost with all those prints. So logging libraries will give us the advanced print capabilities which we need. And it will provide, for example, level tagging, which I find it really useful. For example, in AppsFlyer, we tend to filter in production only error messages. So it's really easy to understand if there are errors and not a lot of prints. And it will provide us information about the line numbers, where it was printed, and the source namespace. And of course, much more, but those are the basics. All those features usually with low overhead on your program performance, which is great, and it's really easy to use it. So let's see an example. I will show here an example from Timber, if you know it. If not, you can check it out. It's a great library, and I personally really like it. A simple example is printing an error message, error log. Here it's just a message, but it can also get some arguments and values and print them to the REPL. And by printing it, I can now see the date and time which was printed, the log level, the namespace, and of course the line number with the message itself, of course. Yeah. So those are some logging libraries. Timber is one of them, and you can play with those libraries. There are much more. Some of them are different, some of them are pretty similar, but it's a really great tool. So to recap what we talked about today. We talked about the stack trace and how even if it's not printed to the REPL, we can get it from the REPL and understand unexpected flows without starting to debug the code and spend a lot of time. We talked about synchronization and how we can sync our data and code together to get fast reloading using the user namespace, the default user namespace. And we talked about code flow debugging and how we can use a simple tool such prints to understand our code flow better. And of course, we talked about mate-clj, a library that will give those prints capabilities out of the box. And we talked about logging libraries, finally, which will give us some advanced print capabilities. And to summarize it all, I think that this is the main point. The REPL is a powerful tool, and I think it should be native to your development flow. It's provide us a lot of utilities and capabilities. And as we say it in AppsFlyer, you should first start the REPL and then start your editor, because the REPLs come first, and it's a great and powerful tool. And every line we write is line that we will debug. So as this quote says, every new line of code you willingly bring into the world is code that has to be debugged, code that has to be read and understood, and code that has to be supported. This quote is by Jeff Atwood, which is a Stack Overflow co-founder, and I think that be able to get a good grasp of a new programming language, especially when you're a beginner, is by being able to debug it properly. And I found that by debugging Clojure code, just boost my Clojure skills. And learning a new language is always fun and exciting. And for me, especially personally, Clojure has proven as a fun ride. And by using the REPL and using the simple and right tools, it was much more easier at the beginning. So thank you, and safe debugging.